Thank you for tuning into my YouTube channel and watching this small short slideshow with video about Ebola. So I thought because there's a lot of information, a lot of things happening in the news almost 24 hours a day, I thought I'd put a small brief information about Ebola and the viruses and how the disease develops and also spreads. So my name is Nityanand Selaya. I'm a senior research scientist and immunologist, currently consultant. I just want to put a disclaimer that I'm not a virologist. Worked with Ebola. I have extensive research experience with HIV and also immunology. So I thought I will just compare the virology experience with immunology and see why the immune system actually could not handle the Ebola virus very effectively. Um, so a lot of information is available in the website. CDC website is a very good source to get more information as well. So as you all know, Ebola outbreak happening in West Africa, which is a very serious issue right now because WHO just reported that there could be 5,000 to 10,000 new cases per week in the West African area. And also US is sending a lot of military equipment and military personnel there to build hospitals and trying to contain the spread within that region. So initially it started in 1976 with the small outbreaks, but now it's very serious in West Africa, um, which is mostly populated area, and that's what I think the problem is. A lot of new people are getting infected. So I put this together just to show you the different numbers developing from 1976 to today. Um, I think I got this from a WHO website. So there's also not only number of cases but also the fatality, because this is a very dangerous virus. It can actually kill a lot of people. It's 50 to 90% fatality or mortality rate with this. So Ebola virus actually a family from the Filoviridae virus, which is a filamentous kind of a virus. If you know HIV, I will just compare HIV back and forth just to because of my experience with HIV. It's actually lentivirus or retrovirus. It comes from retrovirus, but here it's a different family of viruses. So that's one of the reasons you cannot actually the knowledge from HIV cannot be really um, compared to this particular virus because it's a completely different family of virus, and they have three groups, if you will: QR virus, Marburg virus, and Ebola virus. So Ebola virus is what causing a lot of diseases, and there's a lot of research actually compares Marburg virus to Ebola as well. Within the Ebola virus, there are 5 species known as Zaira, Bandibago, Sudan, Western, and Thai forest. So within that, I think the Ebola current outbreaks actually comes from Zaira species. So it's known that most of these Ebola virus actually have a host in those areas. It's known as fruit bats, and people actually comes into contact with whether they are eating the fruit bats or they come into contact with the fruit bats can get infected with this particular virus. So Ebola virus can infect any cells. So as I just mentioned that HIV virus, there's a lot of known about HIV virus. A lot of research went into and identified the receptors specifically and what happens inside the cell. Every step of the HIV viral production is completely known. But Ebola, we know that it can infect any cells. Specific receptor is not known, but it is assumed from the infection. I think it is using a common receptor in most of the cells. Other big difference is Ebola virus actually can replicate very quickly inside the cell. So the virus actually have a tendency to take over the machinery of the cells by the transcription or translation, or packaging, everything. So they just take over the completely and produce their variants or copies of the virus, and then once the Ebola virus reaches a certain level, its cells actually explodes. So these are called cytolytic viruses. So once explode, the viral particles can infect other cells in the body, or it can actually spread to other hosts. So the dendritic cells is an important cell because it's an immune cell which can actually capture some of the antigens and present to T cells, which are another immune cells which are important for protecting us from viral or bacterial infections. So the two things can happen. In one way, it is good that its dendritic cells are infected and presenting. But what happens with Ebola, because it's very quickly replicates, the cells doesn't function normally. So it can have a lot of dysregulated functions, which is actually bad for the immune system. And also these cells can die because of cytolytic effect. So this is one of the reasons the immune system is actually disabled or cannot really fight the virus quickly enough, because they are actually getting destroyed in the process. The other thing happens is when the virus explodes the cells, cellular organelles, or whatever the cells comes with, it's kind of a toxic to the body. So what body does is, once they see these kind of destructions, they mount an immune response known as inflammation. Inflammatory responses create a lot of cytokine production. So that's what's shown here. The cytokines are produced, chemokines are produced. So you're trying to contain that infection within that area. So the immune system actually produces a lot of things to bring in their own protective people, protective cells, and trying to contain it. But unfortunately, this is a devastating blow to the cells. The immune system cannot control it, so they just secrete out a lot of cytokines, which creates inflammation, and also which is one reason makes the people sick early on with the fever and headache, and also the inflammatory responses. Another bad thing happens is the clotting mechanism. The clotting mechanism, blood clotting mechanisms, also disrupted by this virus, specifically the tissue factor and some other coagulation cascade, which can create two things. One, it can create blood clots within the veins, so that blocks some of the blood supplies. So in the capillaries, then the skin actually expands it, and also it can actually, because it uses up a lot of coagulation proteins, it can create bleeding. So it cannot actually work as a clotting. So inhibition of the clotting also can happen at the same time. So that's what this is called as hemorrhagic fever, or it's a bleeding from unknown things. I put this just to show you the structure of the virus, because virus structures are not actually, these are electron microscope studies people do, trying to identify particular proteins, how they assemble. That can give some information for researchers to identify some therapeutic mechanisms, right? So they know there are a lot of proteins involved in the matrix, and RNAs are bundled with nucleoproteins. So there are information is available. It's not completely unknown, but there are a lot of information available, and there are a lot of people actually doing a lot of research as well. So as I said, Ebola virus can cause acute serious illness. The fatality rate is very high. Sometimes 25 to 90% of the people can die because of this viral infection. And the virus can spread from people, from animals to people. Most of the animals are hosts, so they don't get sick, but I think apes and some of the monkeys can get sick as well. And then it spreads from human to human by direct contact as well. So it doesn't spread via sneezing or coughing in the air. So that's been repeated again and again by the CDC, and all of the people on the TV, when doctors comes on the TV repeating that. So it is easier to contain if you are very careful, and with the patients coming in or from the area. So it's directly, but it's because it's very dangerous virus. Even small amount of virus goes inside the body, they can replicate fast and take over destroys most of the cells. So it's really bad. So you have to be very, very careful that you don't come into contact directly. So as I said, symptoms actually is a fever. The incubation period is known as that the virus goes into a body. They actually infect the cell, but they don't really quickly produce it. So it might stay there for a little bit of time, trying to get things started for the production of a new virus. So at that time, the patient doesn't have a lot of virus in their body, so they don't feel anything. And also that's also a good thing because they don't really spread also, because there's a viral amount of virus is very low, so they cannot spread to other people. So once the incubation period is over, that means the virus is set up everything and started to replicate and produce more virus. And when the virus just comes out of a cell as a cytolytic function and spreads into the blood and to the other cells, now the immune system kicks in, trying to contain it, and that's how you started to get symptoms from fever through headache and sometimes vomiting and diarrhea. In that case, now you have the virus actually replicated a lot, so there's a lot of virus in the blood, and now that those patients or person with that symptom now they can spread the virus. So that's what they say, that if you have a fever and if you know that there's a possibility that you might have contracted Ebola from other people, like healthcare personnel, or if you have visited those areas, West Africa, you have to be isolated and contained within a quarantine area. So these things are available. The symptoms and everything is available in the CDC website. So you can actually do that. Diagnosis is very difficult because of same thing, because it's flu-like symptoms. So most of the people, when they go as a flu-like symptoms, they will not have Ebola, because they have not. Ebola is not a common virus in US or most of the countries. So the doctors will not suspect Ebola. But if a person has visited West Africa or any other area where Ebola is in epidemic proportions, then they have to be careful. There could be an Ebola. And also, just happening in Dallas is what healthcare workers who took care of a patient, and if they develop symptoms, flu-like symptoms, they also have to be very careful to rule out whether they have Ebola or not. The lab tests actually can be done to look at Ebola virus in the blood by many different methods. I think one more sensitive method is called PCR, or polymerase chain reaction. So you actually look for viral RNA in the blood. So that is the most sensitive method to look at it. And the immune system also actually kicks in, so they produce antibodies for this particular virus. So there might be some antibody in the blood. People in the lab, they can actually look for by ELISA. I think, I don't know whether anybody as a routine lab test, you don't look at electron microscopy, but I think CDC might be doing that just to make sure that the Ebola virus doesn't change or doesn't give any new information from each patient. So because of that, the labs who test these things have to be very careful as well. They have to take extreme precautions, make sure that the blood or the fluid comes from the patient is contained and disposed properly. I think the 10% bleach will kill almost all the viruses. Again, treatment is also the same thing. There's not any specific treatment for Ebola, and there's no specific vaccines for Ebola. As flu virus, flu, we have vaccines, but as if you have a flu, usually the doctors say drink a lot of fluids, rest, and do those things. So that's easy. But in Ebola case, it's kind of difficult because that's disease development is really fast. So do definitely have to be in an isolated hospital where they can take care of, check your other vital signs and treat with whatever available drugs for some other symptoms. So mainly the electrolytes and blood pressure, they will monitor that, and blood transfusions if you need it, because there could be a lot of bleeding as well. So prevention and control is important. Specifically today as healthcare workers, two healthcare workers got infected. So this is being talked about a lot. So it's important that personal protective equipment or PPE is used properly. In a research facility, Ebola is actually worked under BSL-4 labs. BSL-4 means biosafety level 4 because it's a serious virus. HIV is worked on the BSL-3 lab. Again, when I work with HIV, we have to suit up and make sure we don't expose any skin. And also in a lab setting, we work under the biosafety hood. So there's an additional protection, but with patients it's going to be hard. So your personal protective equipment and how you dress up is very, very, very important. I think everybody's now stressing on that. That's the best way to contain the spread. So I don't want to spend too much time on that, but that's the only way to prevent the spread from one person to the other. Specifically for the healthcare workers, they have to be in the top concern, which is personal protective equipment. Make sure that that is clearly followed, the protocol. And just additional information about prevention, reducing the risk of wildlife to human transmission. That's also these can be done in the West African area. So this education is important. People have to be told that this is a real serious virus. You have to take care of that, and then also you have to work on the human-to-human transmission, and then the containment of the outbreak. So those are the kind of very important stuff I think they are doing at in West Africa right now. In US, because this is a developed country, we have a good healthcare systems, and we have a lot of resources. So I think these can be done easily and quickly. So these are some of the website I took this information from. You can watch on that. But the CDC is, I think, is the best source. So again, thank you for tuning in. I will be posting some of the updates on Ebola if anything comes up new, and then also we'll be posting some other diseases, starting with HIV and some autoimmune diseases, and give some background on the immunology of that. And again, thank you.